All right, welcome back. Here's part 2 of the notes for section 9.3 on polar and rectangular coordinates. So in part 1, we focused on changing polar coordinates to rectangular. Today, in part 2, we're going to focus going the other way. So we're going to go rectangular back to polar. To do this, something you've done before, we're going to use Pythagorean theorem, and we're going to use inverse tangent. So if we have x and y, we can use that as our a and b, if you will, to find c, the hypotenuse, and we can do inverse tangent to find our angle. So just a couple bullet points here. So the first one said basically what I was just talking about. We're going to use Pythagorean theorem and inverse tangent. Second, inverse tangent only determines angles in quadrant 1 and quadrant 4. And so if you're in quadrant 2 or quadrant 3, you're going to have to add 180 degrees to your answer. Or if you're in radians, you're going to have to add pi to your answer. So for example, if you have the point 2, -4, 2, -4 is in quadrant 4, so then your inverse tangent is going to give you your answer going to be okay. If you were at -2, -4, then you're going to have to add 180. We'll go through that as we go. All right, so here's the aforementioned 2, -4. So we know that that is a point that is down here in fourth quadrant. So to get our r value, we're going to square both of those. Remember, when you square a negative, you do get a positive. So really, this is 4 plus 16, or the square root of 20. So our r value is 4.47. When I take the inverse tangent of y over x, -4 over 2, or inverse tangent of -2, my calculator is going to tell me -63.43, which is correct. But if we want a positive angle measure for that, we want our angle to be between 360 and -360, or excuse me, between 0 and positive 360. So we'll add 360 to this, and this will give me the positive equivalent. So 296.57 is the positive equivalent to that angle, and you can see our answer right there. So we found our r value using the Pythagorean theorem, found our tangent, our theta value, using inverse tangent. Another example, 5, 0. This is going to be right on the x-axis. So I'll jump down the answer here real quick. Just come as no surprise that our answer for our degree is 0 degrees or 0 radians, because we're on the x-axis. If we were on the other side, then you would expect this to be 180 or pi. If we were on the y-axis, then you would expect 90 or 270 or pi over 2 or 3 pi over 2 in radians. To get our r value, again, we're just going to square these. So 5 squared plus 0, square root of 25 is also 5. So in this case, the only difference here, 5, 0 in rectangular, 5, 0 in polar, is the fact that this is in degrees. This is our r value, as opposed to this one is our x and y coordinate. Can encourage you at any point when you need to stop and pause for a second. You need to write stuff down, or if you need to go back, feel free to do that. I'm trying to keep these videos as streamlined as possible for you, so you don't have a 25-minute deal to look at here. All right, 6, 8, that's in quadrant 1. So when we do this, we expect to get a positive answer for tangent, and we will. I'll get there momentarily. This worked out pretty good for us. 6 squared, 8 squared. So that's 36, and 64 is 100. Square root of 100 is 10, so that's our r value here. And then we'll take the inverse tangent of 8/6, or 4/3, if you will, and we get 53.13. And you see that our answer then is 10 and 53.13 degrees. If you did it in radians, that's fine. Then you would just put whatever the decimal is for the radian answer here. If they ask you for degrees, you just use degrees. If they ask you for radians, use radians. If they don't specify, then that choice is up to you. For me, I'm going to default to degrees if they're not going to tell me otherwise. All right, good follow-up question here. What if the point was -6, -8? So we know that 6, 8 is in quadrant 1 up here. So if we had -6, -8, that's going to be down here in quadrant 3. Everything we do is the same. So we would still square this, take the square root. We'd still get positive 10. That's fine. The only difference now, because we're in quadrant 3, I've got to add 180 to that theta value. So if I add 180 to this theta value, now I get 233.13. So that's the only difference. R value stays the same. Just add 180 to theta. So that's our answer if this was -6, -8. So you got to be mindful before you start of what quadrant that rectangular coordinate is in before you answer these. All right, another one here. We're back down in quadrant 3, so we know we're going to have to add things here, and in this case it's in radians. So when we get our answer on our calculator, we're going to have to add pi, or 3.14. So I square -8, square -12, so I get the square root of 208. Obviously we're going to approximate that, so 14.42. Take my inverse tangent. Again, make sure you're in radians. And I get 0.98, but that's a quadrant 1 value, so I have to add pi to that. So the correct answer, 4.12. And again, just a reminder here, we had to add pi because our point's in quadrant 3. So here is my polar coordinate, r and theta, that is the equivalent to this rectangular coordinate, -8, -12. We can also change polar equations into rectangular and vice versa, so that's what we're going to focus on these last couple slides. There are a couple things that you are going to want to write in your notes. Make sure you have down your notes and make sure that you remember. And that's these three right here. We know this from yesterday or from part 1. X is r cosine theta, y is r sine theta. The third one we want to remember is right here. R squared is x squared plus y squared. That's really the Pythagorean theorem. Instead of a and b, we used x and y. But you want to make sure that you memorize this third one as well. If we were to solve this for r, it'd be square root of that, but typically we can write it that way. So these are the three things that we're going to use to go back and forth between polar and rectangular coordinates. So polar equation, r equals -3 in rectangular form. If you were to graph this on a polar grid, that would be a circle. And so this is really a radius value. And if you square that, you would get 9. And so in rectangular, for a circle, that's this equation here, but we're at 0, 0. So x squared plus y squared equal to this radius squared. So right there, x squared plus y squared equals 9. Again, with our polar graphs like this, if it's r equals to a number, they're always centered at 0, 0. So we're not going to have to worry about h and k being anywhere but at the pole. And so we can just square the radius and write our circular equation like we did right there. All right, r cosine theta, or it's going to be r equals 6 cosine theta, and we want to write that in rectangular form. So I kind of gave you the hint here. We're going to multiply both sides by r, which we can do, because whatever we do to one side, we can do to the other. That'll give me r squared on the left side and 6r cosine theta on the left. And from slide 14, what do we know? We know that r cosine theta is x, and we know that r squared is x squared plus y squared. So we can substitute here. This is x squared plus y squared, and this is 6x. We don't have to solve this for y. So, I mean, you could carry the x squared over and take the square root. You don't need to do that. So you can just leave this as x squared plus y squared equals 6x, and that is fine. All right, one more slide and we'll be done with this section. This one's a little longer here, so we'll kind of go step by step. So we want to write the rectangular equation x squared plus y minus 1 squared equals 1 in polar form. This is the equation of a circle. So I've got a center point at 0, 1 and a radius of 1, and we want to get this to polar form. So first thing we can do is replace x with r cosine and y with r sine theta. So we're going to do a little substitution here, and you can see that. I'm going to have to FOIL this out right here. R cosine squared, that's just going to be r squared cosine squared. This one I'm going to have to FOIL out. And so if I do that, when I FOIL r sine theta minus 1, and I square that, I get this right here. I will add 2r sine theta to both sides, and I will subtract 1 from both sides. You'll notice here the 1's are going to cancel out. And so I'm going to end up here, again, the 1's cancel out. I can factor an r out of both sides. So I can take an r out here. In fact, I can take r squared out here. I can factor an r out of here. So I'm going to take an r out of both sides, and that's going to give me this. And what do we know? We know that cosine squared plus sine squared is 1. So right there I replaced that with 1. That's how we got r squared here. Now we'll divide that r out. And so I get r equal to 2 sine theta. So again, just to backtrack here a little bit, I took r squared out here, factored that out here. You can factor the r out here. You don't really need to, but really we're going to factor out r squared. Cosine squared plus sine squared is 1. Then I can divide both sides by r to get here. So that completes our notes for day 2 of section 9.3. All right, thanks a lot.